Today we're diving deep into Earth's explosive past. When you hear supervolcano, what comes to mind? Probably Yellowstone, right? Or maybe you've heard about the Campi Flegrei in Italy, which is getting a lot of attention lately. And yeah, those are massive and definitely worth keeping an eye on. But what if I told you they are just the tip of the iceberg? Our planet's history is hiding volcanoes that make Yellowstone look like a firecracker. We're going on a geological detective story to uncover these ancient, colossal giants. So first things first, what even is a supervolcano? It's not just a big volcano, it's a completely different beast. There isn't a strict scientific definition, but geologists generally use the Volcano Explosivity Index, or VEI. This scale, from 0 to 8, measures the power of an eruption. A VEI 8 is the big one, the mega-colossal event. To qualify, a volcano needs to have ejected at least 1,000 cubic kilometers of material. To put that into perspective, imagine the entire Grand Canyon. Now fill it up with volcanic ash and rock. That's 1,000 cubic kilometers. The 1980 eruption of Mount St. Helens was a VEI 5. A VEI 8 eruption is at least 1,000 times more powerful. These aren't your typical cone-shaped mountains. Supervolcanoes don't build up, they blow up. The eruption is so massive that the ground above the magma chamber collapses, leaving a giant crater called a caldera. Yellowstone is famous for its caldera, which is so huge you can't even see it all from one spot on the ground. Now, let's travel back in time. Way, way back. We're going to Indonesia, about 74,000 years ago, to the site of the Toba super eruption. This is one of the most famous and well-studied ancient supervolcano events. Toba wasn't just big, it was earth-altering. It blasted out nearly 3,000 cubic kilometers of ash and debris. That's enough material to bury the entire state of Texas ankle-deep. The eruption was so powerful it created a volcanic winter. The massive cloud of sulfur aerosols and ash shot into the stratosphere, circling the globe and reflecting sunlight back into space. Global temperatures may have dropped by 3 to 5 degrees Celsius for several years, and some models suggest it could have been even more severe in certain regions. This dramatic climate shift would have devastated ecosystems worldwide. There's even a controversial but fascinating theory called the Toba catastrophe theory. It suggests that this volcanic winter caused a human population bottleneck. The idea is that the sudden, harsh climate change nearly wiped out our early ancestors, reducing the global human population to just a few thousand individuals. While many scientists debate the severity of its impact on humans, there's no denying that Toba was a cataclysmic event that reshaped the planet and its climate in a geologic blink of an eye. The caldera left behind is now Lake Toba, the largest volcanic lake in the world, a beautiful, serene landscape hiding a history of unimaginable violence. Okay, now let's rewind the clock even further, to a time before Yellowstone even existed. We're headed to Colorado, USA, about 28 million years ago. Here we find the La Garita caldera. You might not have heard of it, but in the world of volcanology, La Garita is a legend. It's the site of what might be the largest known explosive volcanic eruption in Earth's history. We're talking about the Fish Canyon Tuff. Tuff is the term for the rock formed from consolidated volcanic ash, and the Fish Canyon Tuff is immense. The eruption that created it released an estimated 5,000 cubic kilometers of magma. That's 5 Grand Canyons worth of material. It's almost double the size of the Toba eruption. It is so huge that it is the only eruption that geologists have unofficially ranked as a VEI 9.0, a category created just to describe its sheer scale. The ash from this single eruption blanketed an area of over 30,000 square kilometers, with layers hundreds of meters thick in some places. Imagine an explosion so powerful, it buries a region the size of Belgium in superheated ash. The caldera it left behind is enormous, measuring about 35 by 75 kilometers. It's so old and eroded that it's difficult to see today, blending into the San Juan Mountains. But geologists, by carefully mapping the rock layers and chemistry, have pieced together the story of this mind-boggling eruption. La Garita reminds us that our planet has a capacity for volcanism that far exceeds anything in modern human experience. But we can go even further back, to a time when the dinosaurs were just beginning their reign. Let's travel to Siberia, Russia, around 252 million years ago. This isn't a single eruption, but a whole different kind of volcanic event, the Siberian Traps. Traps comes from the Swedish word for stairs, because these formations often look like giant stone steps carved into the landscape. The Siberian Traps weren't an explosive eruption like Toba or Garita. Instead, this was a large igneous province, or LIP. For about 2 million years, colossal fissures in the Earth's crust opened up and relentlessly poured out insane amounts of lava. It wasn't a bang, it was a flood of molten rock that covered an area of 7 million square kilometers. That's roughly the size of Australia. The lava flows were, in some places, kilometers thick. This relentless outpouring of lava also released staggering amounts of greenhouse gases like carbon dioxide and methane, along with toxic sulfur compounds. The result? Catastrophic runaway global warming and ocean acidification. And the timing is no coincidence. The Siberian Traps align perfectly with the Permian-Triassic extinction event, also known as the Great Dying. This was the most severe extinction event in Earth's history, wiping out about 96% of all marine species and 70% of terrestrial vertebrate species. It's the closest life on Earth has ever come to being completely extinguished. While an asteroid impact might have also played a role, most scientists agree the volcanism from the Siberian Traps was the main driver of this global catastrophe. So why should we care about these ancient, long-dead volcanoes? Because they are the ultimate case studies. By studying the geological record of Toba, Garita, and the Siberian Traps, scientists can understand the full spectrum of what our planet is capable of. They look at the rock layers, the chemical fingerprints of the ash, and the fossils to build computer models. These models help us predict the potential consequences of a future super eruption. How would the ash spread? How much would the climate cool down? What would the impact be on global agriculture and supply chains? These aren't just academic questions. Understanding the worst-case scenarios from Earth's past helps us prepare for the future. It drives the monitoring efforts at active systems like Yellowstone and Campi Flegrei. Geologists use GPS to track ground inflation, seismometers to listen for earthquakes, and gas sensors to sniff the air for volcanic fumes. All of this is to catch the earliest warning signs. The stories of these ancient giants are written in the rocks beneath our feet. They are a humbling reminder of the immense power simmering just below the surface of our planet. They show us that Earth is a dynamic, ever-changing world, and the quiet landscapes we see today can hide a truly explosive history. It's a story of destruction, but also of resilience and change. After every one of these events, no matter how devastating, life found a way to bounce back. Learning about these supervolcanoes isn't about being scared. It's about being awestruck. It's about appreciating the incredible geological forces that have shaped our world over millions of years. It gives us a profound sense of deep time and our own small but special place within it. Thanks so much for joining me on this geological journey today. I hope it gave you a new perspective on the power of our planet. If you enjoyed this video and want to explore more incredible stories from Earth's history, make sure to hit that like button and subscribe to the channel. It really helps us out. Let me know in the comments which ancient giant fascinates you the most. Until next time, stay curious.